Bismillahirrahmanirrahim. Problem number 29 from assignment 4. Let us draw the figure on the board. 1 point. There is another point. The first point is P. The second point is Q. And this is R. Okay. P to Q, 20 meters. So P to Q, this distance is 20 meters. Then P to R, it is D. P to R, it is D. Can anybody tell me what will be this distance? What will be QR?
D minus 20.
Very good. D minus 20. The whole distance is D. From there, you have to subtract this 20, then you will get this distance. Okay. A boy can hear echo at point P after 2 seconds, 0.2 second. Okay. At P point, he can hear the echo, and the time that is taken, that is 0.2 second. Okay. Then the temperature of the air is 35 degrees Celsius. Temperature, it is in degrees Celsius, so I will write in theta. And velocity is 332 meter per second at 0 degree. Acha. Now this is a little bit interesting. At 0 degrees Celsius temperature, we generally know the temperature to be 330 meter per second, right? But here specifically they mentioned to consider the velocity at 0 degrees Celsius temperature to be 332. So we have to consider it 332, okay? It means if we do not know the temperature, it is not mentioned in the question, what is the temperature at 0 degrees Celsius, then we will consider the velocity to be 330. Okay, but as it is given in the question, we do not have any option. If it is 332, we have to consider 332. If it was written 340, we have to consider 340. What I'm trying to say is, if it is not mentioned in the question, then you have the liberty to consider it 330. But if it is given in the question, you have to consider that value only. Clear? So for theta degree Celsius, the value is this one. Okay. So where is my dust? Is my writing clear?
Little dull.
Okay, let me bring another marker. Wait.
देखिए assignment 4 है.
Acha, okay. So theta, from here I will calculate actually T2, that is 35 plus 273. If I convert it into Kelvin, okay, so it will be 308 Kelvin. Okay. Then at 0 degrees Celsius temperature, this is theta 2 and theta 1 is 0 degrees Celsius. So if I convert it into T1 in Kelvin, 0 plus 273, it will give me 273 Kelvin. Okay. Then velocity V1 is given 332 meter per second. V2 we don't know. We have to find out most probably. Then at C, find out the distance D. They told us to find out the distance D. Oh, we can do this very easy. Okay. So, but before that, I need to calculate V2. I need V2. Then I will be able to calculate what is the value of D. Okay. So, how to calculate V2? I will do it on this side. Okay. We know V2 by V1 is equal to root over T2 by T1. Now here V2 is something we have to calculate, and V1 is 332 is equal to root over T2 is 308 divided by T1 is 273. Somebody calculate the value of V2 and let me know. 308 divided by 273 into 332. Right. So V2 will be equal to, what will be the value of V2? Find out.
348.82.
3
348.83.
GM. Oh,
Yeah.
okay. They join করছো না?
Yes, sir. Approximately 10 minutes.
At P, the echo will be heard after, oh, sorry, 0.2 second. 0.2 second. Okay. So to hear the echo, what is the distance that the sound has to cover? See, at the P, I'm hearing the echo, right? So the sound will travel from P to R, and then it will come back from R to P. That means it will travel D distance one, and then again it will come D distance. So the distance traveled by sound, that is 2D, traveled by sound, comma S is equal to twice of D. 2D distance it will cover. So I already told you so many times that whenever we are talking about the velocity of sound or the velocity of light, we are considering uniform velocity if there is no change of medium. Okay, if there is no change of medium, there will be no change of velocity. So if there is no change of velocity, the velocity is uniform. This one we know from the motion chapter. So for uniform velocity, I can put S equal to Vt. This equation I can use, right? So S, I will replace the value of S, that is 2D is equal to V into T. The velocity is this velocity, 348.83. 348.83 into time. The time taken is 0.2. So 0.2. Okay. So find out what will be the answer. What will be the answer?
The answer is coming 34.883.
Oh, if you divide it by 2. Oh, you already divided that side by 2, right?
Yeah.
38.83 into 0.2. Yes, the decimal will just move to one side, one place early, at 34.883 meter. So this is the distance between P and R. Okay. So this is the answer of C. Okay, now we will check D. Before I move to number D, I want to ask you for the last time, is there any doubt here in the whole process? This is the same process that we have been repeating for several creatives. Okay, I gave you so many creatives, many of them are similar. I gave it in this way so that you practice again and again, and the concept, is well settled in your brain. Okay. So this is C. Now we are going to discuss about D, inshallah. Before we start D, let us list up the information that we already know. We know the temperature now, it is 308 Kelvin, and at this temperature, sorry, T2, and the velocity we know 348.83 meter per second. This is the velocity of the current situation of sound. Yeah. So now they are asking, can you hear the echo from point Q? So now, standing here, if you shout, you are hearing the echo, right? But Q is a point that is a little bit forward. So there is a little bit possibility that you might not hear echo standing at point Q. There is a little possibility. So to do that, we have to actually find the distance between Q and R. Can I find this distance now? Okay. QR is equal to D minus 20. Now D, I have found 34.883. Okay, minus 20. So the distance has come 14.883. Okay, from here itself we can say it is not possible to hear echo at the point Q. Why? At 0 degrees Celsius itself, the minimum distance required is 16.5. Now the temperature is higher, right? So bigger distance will be required. So already it is lesser than 16.5, so he will not hear echo. Whatever I just said, if you did not understand, I will prove it with the calculation. Don't worry. So this is the distance, okay? So if we want to hear echo at point Q, the distance traveled by sound. Yeah. If I want to hear the echo at point Q, the distance that the sound has to travel is 2QR, right? From Q to R, it has to go once, and then from R to it has to come back to Q. So twice of this distance. Now QR is equal to, we already found out this distance, so we will double the distance. That is the distance traveled by the sound. So it will be 2 into 14.883. Correct or not? This distance. Okay. Now we will apply the formula S equal to Vt. So it will be 29 something, 29 point something. Can you kindly check?
29.766.
29.766. Okay, so 29.766 is equal to velocity. What is the velocity? 348. 348.83 into the time. We will find out whether the time is greater than 0.1. Okay, that is the minimum time required to hear echo, right? So T will be equal to, this one will be divided, 29.766 divided by 348.83. So what will be the value?
0.853.
0.853.
0.085.
Oh, sorry, 0.083.
It is 0.0853. Now, can you say it is greater than 0.1 or less than 0.1?
Less than 0.1.
Yes.
Less than 0.1. Very
So
good.
we cannot hear.
So this is less than 0.1 second. So as a result, we won't be able to hear the echo. This is the last line that you have to write. Okay. So at point Q, we cannot hear the echo. Last story. Okay, so finish. Okay, the rest of the problems, kindly try yourself. Okay, and submit as assignment. The last time is Friday morning before 9 o'clock.
8:55.
9
o'clock, sir. Why you said 8:55?
8:55, 9 o'clock. What is the difference? Actually, there is difference because if you submit in 8:55,
Yes, sir. 5
you will
minutes.
consider
We
late.
cannot hear that time also echo.
Better.
At much distance.
Okay. So submit before the deadline. Thank you very much for joining. Assalamu alaikum wa rahmatullahi wa barakatuh.
স্যার
বলো।
দ্যাট মিন্স আজকের মধ্যে দিয়ে দিতে হবে না?
কালকে ফ্রাইডে?
কালকে তো ফ্রাইডে।
কালকে থার্সডে।
ও
হালিমা?
না স্যার, আমি ভাবছি কালকে
ওখানে সব উল্টা পাল্টা হয়ে গেছে নাকি? ওকে, ঠিক আছে।